their volume, the shape is not definite. The shape depends on the shape of the containing vessel, and they have a definite volume. Then when you now talk about gases, these ones are not compressible, these ones are not compressible also. But in the case of gases have the highest degree of kinetic energy. Another fundamental property of a gas that makes it unique to all other ones is simply because it is compressible. Gas can be compressed. And also you need to know that the movement here is faster than in liquid and in what? Solid. Then let me now talk about the processes involved. Liquid to solid, it is simply by freezing. Solid to liquid, it is simply by melting. So this one can be referred as what? Solidification. Why this one can be referred as what? Liquefaction. You don't want to call it melting, you can call it liquefaction. Why this one can call it what? Solidification. Then liquid to gas, we have that process. Gas to liquid, we also have the process. Liquid to gas is known as what? Evaporation. Gas to liquid is known as what? Condensation. Why these processes are the same in the sense that the processes is called sublimation, either by solid moving to gas or gas moving into solid. So I've been able to establish the change of states, the interaction between the three states of matter, and how I've also been able to use temperature as a determinant for what? The change of states. So I said that when you have an increase in temperature, the particles tend to what? Acquire kinetic energy and they move with a great energy. But in the case where the temperature is reduced or decreased, then the particles will now acquire what? They will be less energetic. Then also an outline of the kinetic theory of matter: melting, vaporization, and reverse processes. Melting and boiling explained in terms of molecular motion and Brownian movement. Yes, boiling and melting. In the case of melting is attained when a solid is heated. The particles acquire kinetic energy, and as the particle acquire kinetic energy, there is an establishment between the forces of vibration and the what? Binding forces of attraction. A solid is said to melt when the forces of vibration is greater than what? The binding forces of attraction. And in that situation, the crystalline structure tends to what? Collapse. Then in the case of boiling, so I've been able to explain melting, then boiling is attained when the saturated vapor pressure is equal to what? To the external prevailing atmospheric pressure. Then let's talk about the laws of Boyle's, Charles, Graham's, Dalton's law of partial pressure, which we have explained in our previous lesson. It's just to refresh your memory on that. You know that when you talk about Boyle's law, you'll be talking about what? The relationship between volume and pressure. I tell you that is, the volume is inversely proportional to the pressure, provided the temperature remain constant. That is what Boyle's law is talking about. Volume is inversely proportional to what? Pressure. Then in the case of Charles' law is talking about volume is directly proportional to what? Temperature. Then the Ground's law of diffusion. That one is talking about the rate of diffusion of a gas that is inversely proportional to the square root of what? The vapor density. Then Dalton's law of partial pressure. That one states that when there is a mixture of gases which do not react chemically together, it's talking about PT. Dalton's law is PT, PA plus PB plus PC, like that. So with this now, when there is a mixture of gases which do not react chemically together, the total pressure exerted by the mixture is equal to the partial pressure of the individual gases that make up the mixture. We have defined that in our previous lesson. We've been able to discuss that in our previous lesson, so it shouldn't be new again. It's just to refresh our memory. Then objectives. Candidates should be able to, one, apply the theory to distinguish between solid, liquid, and gases. That is what I've been able to do. We establish this kinetic theory. Then deduce reasons for the change of state. Change of state is brought about by what? Change in what? Temperature. Then draw inferences based on molecular motion. Then deduce chemical laws from given expression and statement. That is what we are talking about. The Boyle's law, the Chance law, the Ground's law, and the likes. Then interpret graphically or graphical representations related to these laws. That means that one is talking about our Boyle's law, Chance law, Ground's law, and the likes, which we have established in the previous lesson. Then perform simple calculation based on these laws and the relationship between the vapor density of gases and the relative molecular mass. We've solved so many questions related to vapor pressure and relative atomic and relative molecular mass. And also, there are still some other questions, UTME questions, designed for this topic, just to still refresh our memory. Here are the UTME questions designed for this topic, though we have treated some of them in our previous lesson. 1050 cm cube of helium gas was produced. So when you have it produced, that means it's coming from what? A to B, what? B. So this is the product. And the product is definitely, if this one is 1, this one is definitely going to be 2. So 1050 cm cube, automatically that is our V2, which is 1050 cm cube. Then we have was produced at, so they gave us at this temperature T2, that's minus 33 degrees Celsius. And they also give us the pressure, that's P2, 700 millimeter mercury. Now, what volume would the gas occupy at? So that's T1. T1 is now 23 degrees Celsius. What volume? The question has also been for V1. Then P1 is also given in the question to be what? 750 millimeter mercury. So this is what we have. So if you look at this question very well, the only formula that we can apply here is what? The only formula that will incorporate all these parameters will definitely be what? General gas law, or the general gas formula, which is the combination of what? Boyle's law and Chance law. And the formula is P1 PV over T equals to K, which means PV over T is constant, which implies that P1 V1 over T1 is definitely equals to P2 V2 over T2. Our interest here is to calculate what? P1. So P1, what is P1 from our question? But before we do this, we need to convert the temperature, because we cannot impute the temperature in degrees Celsius. It has to be in what? Kelvin. So our T1 to convert to Kelvin will be degrees Celsius plus 273. That's how to convert to what? Kelvin. So what is the degrees Celsius for T1? That's 23. plus 273, and that will give us 300 in Kelvin. Then T2 will also be degrees Celsius plus 273. And what is our degree Celsius here? Minus 33 plus 273, and that will definitely give us 240 in Kelvin. Then we can now come back here. P1, 750 times V1, that is what we are looking for, over T1, that is T1 is now what? 300, which equals to P2, 700 times V2, 1050, divided by T2, that is 240. Then we are looking for this, so V1 will definitely be 300, we cross multiply this and divide. 300 times 700 times 1050 divided by 750 times 240. Then let's use our calculator to figure that out. 700 times 300 times 1050 divided by 750 divided by 240. We are going to have 1225 cm cube, which according to the option, there is no suitable option here. That means that the option, the correct answer cannot be found in the option, because option A is 1208.67 cm cube, B 794.59 cm cube, C 912.16 cm cube.